Welcome to myprojectbazaar.com. Now we are going to discuss about the project detection and identification of artificially ripened fruits using MATLAB. Now we are going to discuss about the abstract of the process. Fruits at any given time has different maturity levels. Therefore, it is necessary to recognize the appropriate patterns to determine the level of maturities. Maybe it will having the low maturity, or else it will having the more than the above maturities. One of the recognition patterns of tomatoes or any other fruits and vegetables of an image is to use the texture and color analysis. Texture analysis can be proposed using the Gray Level Co-occurrence Matrix, that is the GLCM algorithm. GLCM is chosen because it is an higher degree of recognition based on the value of the contrast, correlation, homogeneity, energy, entropy, and some other points. Furthermore, for color analysis on the one of the methods that can be used in this process, that is the HOG, by utilizing the features and object with the certain colors can be detected and reduce the influence of the intensity of light and then other outside sources. The result of GLCM calculations can be classified to determine the maturity level of fruits, whether the fruit is having the good quality or else the fruit is having the bad quality, whatever the fruit's quality may be. Hence, we have to detect the features by using the GLCM method. By continuously after applying the GLCM, we are going to apply the K nearest neighbor classification to detect whether the quality of the fruit is the good or bad. Hence, we are simply using the classification. Then the performance of the classification will be estimated based on the performance parameters like accuracies. By using that accuracy only, we can justify our processes doing good or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The module consists in this project is input, pre-processing, segmentation, feature extraction, classification, and finally performance estimation. At first, the input stage. In this input stage, the input image is taken from the dataset. The dataset having the different kind of fruits type. After getting the any one image from the dataset, we have to detect the pre-processing. In this pre-processing, we have two kinds of steps is there. One is the image resize, then the another one is the grayscale conversion. In this resize, we have to resize the image into a particular size of 256 cross 256, which means the size of the row will be the 256, size of the column will be the 256. After converting the image into a 256 cross 256 size, we have to convert the image into a grayscale format, or else the separating the RGB channels. So if the input is having the color image, means it have to segregate the channels into an RGB. Why we go for the channel separation in this sense? During the segmentation, if it is an RGB image, means it will be difficult for the segmentation. So that reason the RGB channels will be separated and then it will be converted into a grayscale form. Then the grayscale image will be the input for the segmentation. Here we are using the threshold based segmentation to extract the region of the fruit. After the extraction of the region, we are just move to the next step of the project, that is the feature extraction. In this feature extraction, we are going to extract the features by means of the algorithm named as GLCM, that is the Gray Level Co-occurrence Matrix. After extracting the features by using this algorithm, the classification will be carried out by means of the KNN classifier. KNN in the sense K nearest neighbor. In this classification, we have three kinds of input for the classifier, that is the test feature, train feature, and target. The test feature represents the feature of the input image. The train feature represents the features of the overall dataset image. Then the target represents the number of categories. For example, in my dataset, we have 5 categories of fruits. In the sense, we have targets like 1, 2, 3, 4, and 5. Finally, the classification results will shows the which type of fruit it was recognized. Then finally the performance estimation. In this performance estimation we have three kinds of performance, in the sense accuracy, sensitivity and specificity. Based on these three parameters we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first open the MATLAB 2015B and change the current directory. If you want to execute the file, just right click in the main_GUI.yam and select the option run. Now the user interface was open. In that user interface you can see the several push buttons in the right side for the controlling actions, and then the several axes and tables in the left side for display purpose. First of all, click the button input image. After click this button, dataset will be open. In that dataset you can see the several image types. You have to select any one image from the dataset. After the selection of the corresponding image in the dataset, the corresponding image is shown in the axis 1 with the title of input image. After the input, we just move to the next step of the process, that is the pre-processing. In this pre-processing, we have two stages of pre-processing. The major stage is the resize and grayscale conversion. In between, we have to include the filtering the image. If the input image is having the filter noises, in the sense it should be remove the noises by using the filtering method. The figure 2 indicates the noise removed image. If it is having the any noises, it will be removed, or else the image will be the remain same. After the filtering, we just move on to the next stage of the pre-processing, that is the image resize. In the image resize, we have to resize the image in the size of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After resizing the image, we just move on to the third stage of the pre-processing, that is the grayscale conversion. You can see the difference here. The RGB image having the some color channels, in the grayscale image only having the single color band, not the RGB bands. After done the pre-processing, we have to extract the features from the image. By clicking this button, we have to extract the features like GLCM features, HU features and histogram features. Mainly we have considered the GLCM feature and histogram features. Why we are considering the GLCM feature and histogram feature? In the sense, GLCM feature will extract the textures features from the image. Then the histogram features will extract the color patterns from the image. Then these three features are combined together to generate the test feature like this. This is the values represents the test feature. This is the value represents the GLCM feature. This is the value for hue features. Then this is for the histogram features. After extracting all the features from the image, we just directly move to the classification step. In this classification step, it will recognize which kind of fruits is this. So here we are found the fruit type as the grapes, hence it is displayed in the message boxes. After the classification, we just move to the performance estimation. In this performance estimation, we have three kinds of performance, like accuracy, sensitivity and specificity. These are the values of accuracy, sensitivity and specificity. Thanks for watching this video.